Hello everybody, welcome back. When we left off, we were right at a theorem, let's go, that said if a series converges, then the limit of the sequence, as n goes to infinity, is 0. That's where we were. It's essentially a test for divergence, because if it's not 0, then it doesn't converge. For example, test, let's see, series 1 minus 1 over 2 to the n, as n gets big. And if you recall, the we just want to test this for convergence, and if you recall, the sequence 1 minus 1 over 2 to the n is 1/2, 1/3, 2/3 rather, 3/4, 4/5, etc. And the limit of that sequence 2 to the n is 1. Therefore, this series diverges. That was chocolate. Let's try to get better. Divergence. Oh boy. Okay. So here's a huge series that we want to test the convergence, and actually the converse of the theorem is not true. That is, if a limit of a sequence is 0, it doesn't necessarily converge. And here's the prime example. This is called the harmonic sequence. The series. The harmonic series. It's so called because, you musicians, help me out here. Wavelengths of a string, the overtones of wavelengths of a vibrating spring are in this sequence. That's the sequence. H then 1 over n. That's the sequence. 1 over n. And we want to test whether the series 1 over n converges. 1/2 plus 1/3 plus 1/4 plus 1/5, etc. We want to test whether or not that converges. And it's going to turn out that it's not going to be. Let me just write out some more terms. I'm going to go up to 1/8. 1/6, 1/7, 1/8. And now I just want to show you why it doesn't converge. What I'm going to do is I'm going to make sure that, I'm going to start and replace 1/3 with 1/4. Think about this. 1/2 plus 1/4 plus 1/4. Plus, and then this will be an eighth, an eighth, an eighth, an eighth, plus 1/8 plus 1/8 plus 1/8 plus another eighth. And now what I'm suggesting is that the first sequence, the harmonic sequence, is greater than. This one here is actually less than the harmonic sequence. Because what did I do? I replaced 1/3 with a 4th. And a 4th is less than a 1/3. If I cut something into 3 parts, it's a bigger part than if I cut it into 4 parts. And then I replaced 1/5, 6th, 7th, with 1/8, 1/8, 1/8. 1/8 is 1/5 is bigger, 1/6 is bigger, 1/7 is bigger. And this goes on, and I'm going to keep doing this. Now, this is the lesser of them. That's a half. That's another half. This will turn into 1/2 plus another half plus another half plus another half. And clearly, as n gets big, I can introduce as many halves as I want, which diverges. So, and if this sequence diverges by the comparison test, a lesser sequence diverges, certainly then the one that's greater must diverge at all. So harmonic sequence diverges. Diverges. Oh boy. I need bigger board space, as you see. Okay, This is going to go, got a couple more minutes left in this one, I think. Let's see. Yeah. Anything, any other example for that one? Clearly, but yes. One more, just test convergence of this series. 1 over k plus 2 times 1 over k plus 3. As k starts from 1 and goes to infinity. Investigate the convergence of that. Did one more example for this particular section. And now, if you recall, you would break this into partial fractions. Remember, you do a over k plus 2 plus b over k plus 3, then you multiply. And, but if you do that, you would say that this sequence is actually 1 over k plus 2 minus 1 over k plus 3. If you do that with partial fractions. Now, let's write them out. Start with a third. Okay, so if k is 1, this is a third minus a fourth. When k is 2, I'll put these in parentheses like this for now. When k is 2, this is a fourth minus a fifth. And I'm putting those in parentheses as such. Plus, and hopefully you can see what's going to happen. I'm going to group these two together, and that's going to be 0. And then the fifth, I'm going to group that together. Let me rewrite this down here. This series is equal to 1/3 plus 1/4 minus 1/4 plus 1/5 minus 1/5. Plus, am I doing this right? Yeah. Plus 1/6 minus 1/6. These are the ones grouping together. Right, yeah, we are doing that right. Okay, now I just want the last one. Plus 1 over n plus 2 minus 1 over n plus 3. And now this is going to, everything from here on out is going to go. So you're left with 1/3 minus 1 over n plus 3. And so that's what the sum of this sequence is. And now, so we want to know the limit of that. The limit, as n gets big, of 1/3 minus 1 over n minus 3 is 1/3. So therefore, this sequence converges, and its sum is a third. The sequence, the series, k plus 2 times 1 over k plus 3 converges, and the sum is a third. Sorry about that sloppiness at the end there. Cut. Thank you. See you soon.